Hi guys, good morning. So Zahir here. Again, I am just going to solve a lead code question in front of you guys. So this one is based on linked list, and I'm going to solve this question in front of you guys so that you could actually understand what sort of algorithm I'm using, how I'm actually solving this question. You'll get a brief idea about like the approach you are going to use when you are solving such type of problems, right? So without wasting too much time, I'm gonna start off this question. So first of all, I just need to share my screen, so I'll do that. Yeah. So this is the question which I'm going to solve today, right? So this is simply odd even linked list. So initially we'll be given one linked list. What we need to do, we just need to separate all odd nodes together, followed by the even nodes. That's pretty simple, right? And there's some condition which our code need to just follow that the space complexity should be like order of 1 and the time complexity should order of n is the number of nodes, right? So let see the first example here. You can see the input is like 1 2 3 4 5 in null, and if I do this thing where on this example, then it should like separate all odd node together, then followed by the even node. Then the output should be like 1, then 3, then 5, then 2 and 4. All the even node should be like after the odd nodes, right? So this how you need to solve this question. So there's some constraint here. The relative order inside both the even and odd groups should remain as it was in the input. Yeah, okay, that's fine, because the order should be in the same as in the input, right? And again, yeah, you just need to consider the first node as odd node and the second node even, and so on. Also, we have given the linked list. The length of the linked list is between like 0 to like 10 raised for 4. It means like 10,000, right? Maximum in the linked list there would be like 10,000 nodes present. So yeah, here you just need to write your code. So this they already given the like definition of single linked list here. They already create a structure for us, like a list node. Here we have the int value and the next pointer, and they have few constructors right inside this one. So yeah, so how will approach this question, right? What we can do, we'll use like two pointers, right? Again, that would be like pretty simple, because we just need to iterate once, because we just need to consider the time complexities order of nodes. And starting from the 0, if like 0 is the order of node will be start from 0, right? 0 index, and it will keep going till null point. And if I'm using two pointers, the first pointer will keep the record of the odd nodes, and the second pointer will keep the record of even nodes. And whenever like I'll keep incrementing the even pointers. Once I get the even nodes, I will do, I will um, just copy the nodes to the uh, odd number places, and keep incrementing those values. The pointer that will actually help us to just separate the even and odd numbers, even and odd nodes who, yeah, were this. So yeah, I'll explain you from here so that you could actually understand what exactly I said, right? So basically I will use two pointer again. Sorry, node. One is for even even one. First one is for odd one, that will actually start from the head, and second one is for like even one, that will start from the uh, head to next. Yeah, oh, sorry, that's all. So I'll just make a comma, right? Initially, let's suppose if this my linked list, right? If this my linked list, 4 and 5. So initially my odd pointer will be available here, and the even pointer will be available here. So I'll increment my odd pointer. I'll increment, sorry, it should be like even pointer, sorry, even. Increment my even pointer when is reached to the odd values. What I will do, I'll increment my odd pointer and just swap it. Just swept 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 it. Right? Just swept it. Will that gonna work? Will that gonna work? Will that gonna work? So because if I swept it, right, then 3 will comes here and 2 will go here, right? That's fine. Then again, my this one is at like even pointer and this is at odd pointer. If I increment this, I'll keep the record and I'll keep the record and I'll keep, yeah, no, that will work. That will work. But which one thing is not following here is like is it's not following the rule of like our input order should be same. Output order should be same as the input order, and that's not working here. That's failing here. So we need to think of differently so that the order should remain same, right? So for that, okay, I'll do one thing. What I will do, yeah, that would be nice. That would be nice. Yeah, 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 yeah. Got it. So, so I will actually use like two linked list, right? Initially I just want to break the linked list into two linked lists, so that in the first linked list I'll try to store all the odd node, and the second linked list I'll try to store all the even nodes, and ultimately if I completely iterate throughout the linked list, ultimately I'll just merge about the linked list. So that will actually give a result with the given constraint in the sense that will keep the order same, right? And that's how we need to do. So for that, that will be like pretty easy. For that, what I will do, first of all, I'll for odd node, right? Well, I'll create one dummy node, less node, one dummy node where I need to store the even node. Dummy odd is equal to new less node of zero. Yeah, this will be my dummy node. And this in this node, what I need to do in this node, I'll try to store the even elements, even nodes, right? I just need to separate, and odd node will keep in our initial linked list. And finally, when I completely separate both odd and even, I just need to merge about the linked list, and ultimately you'll get the result. So I'll not do this thing. I'll use one previous and one is like current and while current while current I'll keep the record of int I is equal to start from I, so that this integer will like this variable will count the count index, will keep record of like whether it is odd or even. It will actually help us to just depict, right? So this loop will go ahead, and so inside this one just wait, I'm getting a call. I'll just pause the recording. Hello guys, so I am back. Extremely apologies, actually I was getting a call, right? So it was a bit important call, so I had to pick it. So sorry. So where I was, yeah. So here I created a dummy out note where I'll add the even linked list, even notes, and yeah. So here I'll create a count in index variable which will keep the record of like whether it is odd or even, right? Initially it is odd as the value is 1, so it is odd. So I'll create if count note count index percent 2 is equal to 0. If it is even, what's happened, right? If it's even, then we just need to get that note from the given linked list and try to add the linked list into the dummy node linked list, right? So here I'll create one list node pointer, list node even which will be like dummy node, dummy or dummy even yeah, dummy even. It should name like dummy even, so it will synchronize with the name dummy even, right? So where, yeah, when my note is even, then what's happened, like previous of next is equal to current of next, current of next. So directly the previous like where I created that linked list, yeah, here initially my previous will be here at one previous will point to 1 and current will point to 2, right? When my current reached to 2, at that time, it is even list. So I just need to remove the 2 from this list and try add this 2 to the dummy list, right? So here for your explanation, I mean creating a dummy list. Here I just need to add 2 like this, right? For that, what I'm doing, I'm here, it is my previous list, so my previous will now directly point to 3, so this 2 will get out from the this list. And now next we just need to add this list to the even list. For that, even of next is equal to current, right? Current, got it? Current is this one. So now this list will be like 2 will remove from here, and now let's become like this, as 1 is pointing to 3, and like this. And again my count index will increase. Count, I'll make it, my count index will increase. It will keep the record of whether it is like odd index or even index, plus plus, right? Now my count in my previous of next goes to current of next, right? So when this one reaches there here, so if it is like even number, right? If my current is like, I just need to make this current is equal to previous next, current is equal to previous next. Now my current will point to 3, right? And my previous will be at 1. In this case, what happened, 3 is odd, because yeah, 3 is odd in the initial list. So it will the 3 will not remove from the list, it will just keep the 3 as it is in the linked list. Just I just need to increment the values of both current and list, current and this previous one. So previous is equal to previous of next, previous is equal to previous of next, and current is equal to current of next. Got it? Yeah. Now it will work. So when now my current initially the count index will be one. In one case, the two will remove from the list and go here. When the count index will be at three will be here. It is odd, so it will just increment. Now my previous will be here and current will be here. Now current is like pointing to the current is like evens, right? So again the three will directly point to five and four will be removed from this list and four will add to this list. Here it will be 4, right? Now my previous current will point to 5 and previous will be at 3. Now at this point the current is like, yeah, now current is out, it will increment, previous will also increment and current is also increment. Now current will be at null, so at that point it will come out from this loop. And now what I need to do, I just need to merge this list after the list. What I need to do, the final list, I just need to 1 3 5, and after 5 it should be 2, and after 2 it should be 4. This should be my final list. For that I just need to merge this list after removing the dummy node. So for that what I will do, this my ending of loop, right? Where is even number? Yeah. Even of next is equal to current. Even of next is equal to current. Yeah, I have to also increment the even is equal to even of next. Yeah, that's fine. So now what I need to do, previous will be at 5, right? Previous of next should equal to dummy of next, dummy of next, and ultimately we just need to return head because head will be um, always out. So I'm done with my program. I'll run it and I'll test it. What's okay, I got it. Because like dummy even, I had named this pointer as dummy even, not dummy, where it is. Yeah, control V. Okay, what's wrong? Why it is not 1 2 4 1 2 4? Okay, why it is giving some stupid answer over there? 1 3 5 1 2 4. What's happening? Okay, initially from where it is starting, previous will be at head, previous will be here, and next will be previous will be at like, okay, it should start from 2 because it is odd even number, because I'm already starting from the even number. What's wrong here now? Current index is equal to 2, right? 1 current index is equal to count will start from 2. That's fair enough, because if it is 2, right, then my previous of next is equal to current of next. Previous of next is equal to current of next. Current of next, that's fair. Current is equal to head of next, that's fair. And even of next, even is like dummy even. Even of next is equal to current, that's fair. Even of next is equal to current. Even of next is equal to current 2, that's fair. And current is equal to previous of next. Current is equal to previous of next is 3. Also current will be at 3. And even is equal to even of next. Even is equal to even of next. Okay, fine. Then my it will be here. It will be here. And count index will increment. When my count index it goes to 3, right? When my count index goes to 3, count index goes to 3, it will be here 1 in 3. then my previous will be 1 and 3. So count index will be at 3, then current is present and it's not equal to, then I just need to increment previous will go to 3 and current will go to 4. Again my count index will get increment and it will be even number, then previous of next will be 3, previous of next directly point to 4. That's fair. Previous of next is directly point to 4. Previous of next is equal to current of next. That's fair. And even of next is equal to current. That's fair. Even of next is equal to current. Current at the time it is 4. And current is equal to previous of next. Current is equal to previous of next. Current is equal to previous of next. Current will go to 5. And n is equal to gain of next. Then count index is again increment. It will go here and do all these things. Previous will also increment. At that time 135 and at 3 my previous will point at that time point to 3 and my current will point to 5. At that time previous will also increment and current will also increment. Previous will increment to current is also increment to next and count index will increment. Now current become null. That's fair. Then previous of next, previous will be at 5. Previous of next is equal to dummy even of next. That's fair. It should run. I don't know why it is not running. If I'll start from 0, I don't know. It shouldn't work. It should only work with 1. But with 1, it shouldn't do this sort of things. With 1. It will also give time limit access. I don't know. It will. Current is equal to head of next. It is fair, man. It's fair. It's fair. I think. What's the problem? Store the even elements new list node of 0. That's fine. Even is equal to dummy even. That's fair. Count of index will start from 1. Count index will start from 2. Count index will start from 2. So the problem is like count index is right. Even like this, the even linked list at the end, yeah, this even is like pointing to both the lists, right? We just need to make it null. Yeah, we have to make it null, otherwise it will point to both the lists and it will keep going ahead and ahead and will go to infinite loop. In of next should equal to null, right? So now it should work, I guess, because I'm done with all the part. Yeah, it's giving correct result. So what about the edge cases, right? Like if head is equal to null, head is equal to null, or head of next is equal to null. I mean, if there is only a single element present in the list, they just need to return that element. Return head, right? Also, if yeah, if there's two element, we just need to return the two element because it's already in order, in order. If next of next is equal to null, you just need to return head. For example, I'm just showing you the custom test cases. like if I have only single element, right, one, it should return one directly because it's already a single element present. It means the odd nodes are present. Yeah, it's correct. If there is two element present, 1 and 6, it will directly return 1 and 6 because we don't need to just make him order. It's already in order, right? 1 and 6. That's why if there is an empty list, it will return the empty list. That's all. Yeah, that's why. And like if I make a list like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it will also give the correct result. Yeah, 1, 3, 5, 7, 9, 11, 2, 4, 6, 8, 11. So I think it will accept right now. Yeah, it has been accepted. My code has been accepted. You can see here it has been like accepted. You can also check the like how many test cases I had passed. Like there were 71 test cases, and my code already passed like all the 71 test cases. And my runtime is like 20 millisecond, and memory I did use is like 9.7 MB. Okay, guys. Hope you guys did understood what exactly I did over here. So I'll stop